Hello, my name is Alexander Smolyanskiy, and this is a continuation of my last video where I'm building an autonomous RC car. In this video, I actually get the car to drive autonomously, as you can see in the video in front of you. The platform of the RC car uses a Jetson or a Nano to compute everything on board. It also has a Z Mini stereo camera. Right now, I don't actually use the depth of the stereo camera, so this would work with just a normal camera. I've also changed a few things from the last video, so if you want to see a more detailed explanation of the actual platform, that's in the previous video. But I've changed a few things. I replaced the motor for a rock crawler motor so that the car can drive at a slower speed. And the rock crawler motor has a speed controller built into it. So now what I'm doing is I have the Jetson sending serial messages to an Arduino, and then the Arduino controls the speed controller in the rock crawler motor and then also the servo motor. I am also able to stream video to a local web server so that I can look at what the cameras on the car is seeing from my laptop. And the local web servers run on a hotspot, which the Jetson creates, to which I can connect to from my computer so that they're basically on the same Wi-Fi network, but there's no actual Wi-Fi. And then I also am able to remotely control the car from an Xbox controller using just UDP sockets. First, I created a convolutional neural network to find where the cones are. And so the neural network outputs a mask with each pixel having 3 channels, which is 0 being just its background, there's no cone there, 1 being it's a green cone, and then 2 being a red cone. So the neural network is able to differentiate between green and red cones. And I'm using this where I'll most of the time have the green cones on the left side or the inside of the road, and then the red cones on the outside or the right side of the road. And that's just so that it's easier for the car to find gates and so that it's going in the right direction. And the neural network uses cross entropy loss to essentially get not percentages. I get percentages later using softmax, but I get values of the likeliness of a red or green cone being in that pixel. I trained the neural network using a data set which I made. The way I made it is I just took the camera, walked around different places inside my house, outside a bit. Then I took pictures of cones, cut out the background, and then I just wrote a program which would randomly put the pictures of cones at random sizes and brightnesses into the pictures of just my house or outside. And then I also made masks for that, where I'll, again, just have a mask where each pixel has 3 channels, either 0, 1, or 2. And I trained the neural network on this. And with the size of my data set, it took around 30 epochs to train. And it works all right. There's still some improvements I want to make, but for now, it works pretty well and robustly. I then just drove around a track which I made outside to get video on which I could debug and test. So that's what you're seeing in front of you. And I ran the neural network on it. On the right, you can see the mask it's creating. So right in the mask, you can't see the differentiation between red and green, but you can see black is the background, and then white is where it sees cones. And then also what I'm doing on the left is I'm finding the 2 closest cones through the area of the blobs in the mask, and then I'm drawing a gate between them. Then later what I do is I find the center point in the gate so that I know where the car's supposed to go to. I find the angle to that center point, or the heading angle, and then I use a simple PI controller, which is just a PID controller, but I don't use the derivative part. So I use that PI controller to control the car's steering, which you'll see in this video now. This is my RC car, and it's able to steer towards a gate made out of 2 different cones. First it uses a convolutional neural network to find where the cones are, as you can see on the screen. And it's able to differentiate green cones and red cones, which helps it find the gate. So it finds the 2 nearest cones and then creates a gate between them. You can see that it draws a line between the 2 cones, and then there's also a green dot representing the center of the gate. I then calculate the angle of that green dot or the center of the gate to the car using projection.
or inverse projection. And then what I do is I have a simple PID controller, only without the derivative part, to control the steering. So it follows where the gate is.
In this video, the car is driving fully autonomously by itself. After I had it working with the steering, I just needed to turn on the motors to actually move the car forward, and then I made a track with the green cones on the left side and the red cones on the right side, and then I let the car drive. At first it was a bit wobbly, so I just adjusted the proportional gain and integral gain in the PI controller, and eventually I got it to a good point where it was able to drive for as long as you wanted around the circular track. If you want to check out any of the code, I will put the link to the GitHub for this project in the description. And thank you for watching.